Well, good afternoon and welcome to the September edition of the Draper Natural History Museum's Lunchtime Expeditions series. Where did the summer go? It was here. I know it was. Still feels like it today, but boy, it seems like every year. Maybe it's just I'm getting older, but every year seems to go a little bit faster. And I'm ready for summer. Maybe next week I could start. It is first of all, before I go any further, now's a good time to remind you, please, to turn off any of your electronic devices, anything that might beep or jingle or whatever in the middle of a talk. I'm Chuck Preston. I am the Senior Curator of the Draper Natural History Museum here at the Center of the West. And on behalf of both the Buffalo Bill Center of the West and the Draper, I want to welcome you here. Of course, all of our programs are brought to you through the Nancy Carroll Draper Foundation and Sage Creek Ranch, and so we're pleased to thank you very much for that support, those of you. And I also want to thank, of course, Bonnie Smith, who is our program coordinator and coordinates all of our lecture series, and Corey Anko in the back now, who is videotaping everything with permission, of course, of the speakers, so that as we put these up online, that you can watch them again or tell your friends about them and have them come. It is always a pleasure, a special pleasure, to welcome a friend. And our speaker today and I have been friends now for a few years. I can't even remember when and how we met initially, but it's been a great relationship. I know I've learned a great deal from her, and the work that she's been doing is just spectacular with the Nature Conservancy. She is the Director of Science now for the Nature Conservancy's Wyoming chapter. She earned degrees in geography from the University of Wyoming and the University of California at Davis. In her research, she focuses on a broad range of Western conservation issues, especially landscape-level issues, which include, in addition to her work on the impacts of energy development on wildlife, conservation strategies for long-distance migration routes of big game, and the evaluation of wetland and streamside health, so no moss growing under her feet. She is the current past president of the Wyoming chapter of the Wildlife Society. She's published more than 20 scientific papers related to her ongoing research in Wyoming, specifically, and then, of course, the American West in general. So please help me welcome Holly Copeland.
Thank you for that wonderful welcome, Chuck. I'm going to stand over here because this is really tall, and it's thank you all for being here today and taking a little time out of your life to learn about wind energy in the state and wildlife. This is something I've been studying for the last several years now, and specifically looking at the patterns of wind energy that were coming our way. And the impacts to wildlife. So I'm going to cover kind of that broad topic, and then I'll talk to you about, I know the talk was titled Smart Sighting, so I'll talk to you about some of the things that we're doing at the Nature Conservancy to try to minimize these impacts to wildlife. And I'm going to start here. Some of you may have seen this map, but I think a good place to start is just to understand the wind energy resource in our country. So this is a map of wind speed in the United States, and you'll see that Wyoming has the bluest of all of our country. So we sit at some of the best wind resource in the entire nation. So I'll ask you this question. Given that we sit at the best wind resource in the country, which states do you think are producing the most wind energy in the United States? Anybody have a guess? I heard California, Minnesota, Texas. So here's the map. Here's the map of wind energy capacity currently. So Texas is our lead state for wind energy production, followed by Iowa, interestingly enough, kind of a surprise, Oklahoma, Kansas, and California. I think the California one's pretty interesting because if you remember the map we just looked at, like, hello? This is sort of wouldn't have expected that. Nonetheless, they have a huge consumer base for that wind energy. So I think that's part and parcel to why. So why? Why is it that, oh, by the way, Wyoming, 15th on the list currently for wind energy in the country. So why is that? Why are we 15th given that we have the best wind resource in the country? And so the answer is, it's been explained to me, and I'm no electricity expert, but what has been described is it has to do with how the electricity grid in this country is set up. And so we in Wyoming here are part of the Western Interconnection Grid. We are completely divorced from the East in terms of our electrical grid. So any electricity that we produce is going to go to California, Colorado, Oregon, Washington. We can't send it to Chicago, for example, and they're one of the biggest consumers. So because of that, because the transmission lines don't exist, and because our consumers are far away on the coast, we have been, I would say, kind of protected from that development so far. Other states, like Iowa, that sit right next to Chicago and have a fairly good resource, have been developed quite quickly. It's why I think they're the #2 producing state in the country. Texas is in its own grid, so they can do whatever they want, and they apparently have done so. So it's all about transmission. We've got to get the electricity we produce to the consumers that want it. So currently, we have 1,500 megawatts in Wyoming. There's actually 8,000 megawatts that are proposed, and I'll show you a map of that in just a minute. But on the table of companies that have applied for permits to produce in Wyoming. Technically possible, we have over 350,000 megawatts technically possible, just given our wind resource. So looking at that graph, we have a lot of room to grow. If you want to produce electricity, we have a lot of space and capacity to do so. I put this chart up here because California in particular is a state that is trying to get to 100% carbon-free energy. They actually have a stated goal to do that. Their capacity that they need to get to in order to do that is 200,000 megawatts. So they need to go looking around the rest of that western grid to find that energy resource so they can build out and achieve their goals of clean energy by 2050. So they're, of course, looking to states like Wyoming as a place that they can meet that goal. And in fact, last month, I had some colleagues from California Nature Conservancy visiting Wyoming because they were helping California produce a plan to achieve that 100% clean energy goal. And they had never been to Wyoming. And they were curious if any of these wind energy that's planned in California might be of concern to us. And I said, yeah. You'll see why in a minute. And so we spent a couple days actually just touring them around the Shirley Basin so that they could see these places and understand our concerns. And they walked away with a much richer understanding of why we might be concerned about all this energy that California wants to produce. So here's a map of current wind energy projects in the state of Wyoming, the blue dots. Again, not very much, 1,500 megawatts. This is, the orange areas here are all the proposed projects on the table. Quite a bit in the Shirley Basin. Then of course here over in eastern Wyoming. Some down here by Evanston. This is a map of all the Met towers that have gone up in the state of Wyoming. This is a density map. So Met towers are what companies use in order to investigate further the wind resource so they understand what their capacity could be. And so actually a great way to see where companies are looking for wind is to see where they've put Met towers, because they've gone to the trouble to install these Met towers. It means they're looking at them as a resource. So definitely Shirley Basin, far southeast, over here by Elk Mountain. This is the Chokecherry Sierra Madre you've probably heard about. So let's talk a little bit about the ecological footprint of wind energy development. They're extremely tall structures, actually 500 feet tall, bigger than a Saturn rocket. Here's a picture just kind of for reference of a modern wind energy facility. A pretty large road network. They have to install really big cement footers in order to keep these very tall structures up. So huge cement footers are built, and then a road going to every single one. So what that means is that the physical footprint of a hypothetical 80 wind turbine wind energy facility would be 210 acres. But when you take the entire project area, and we typically use about 200 acres per turbine, a typical wind farm would be over 1,600 acres of land area that would be occupied by that road network. And then ecologically, we would consider there could be a much larger footprint in terms of eagle use and other habitat use of animals that you could also legitimately factor in from a scientific impacts point of view. So sorry for all the numbers here, but the point that I want to make is that there was a study done by a Nature Conservancy scientist, Rob McDonald, and he looked at the landscape level impact of different types of energy in terms of their land use efficiency. And so, for example, this is the direct footprint of each of the different types of energy you could produce, everything from kind of conventional shale gas, tight gas, coal, wind, hydropower. So every single sort of type of energy we'd use is on this list. And then their landscape level impact based on how many megawatts they're producing for land area. And it turns out that wind is 126 kilometers squared per terawatt hour of energy. It's one of the worst it's the second worst on the list, only next to biomass, which, you could legitimately argue is kind of questionable because that one's trees, and well, maybe we need to cut those trees anyway. So from a sort of conventional energy standpoint, it uses up the most landscape footprint for the amount of energy that you generate. Here's a map that I did just to understand this footprint for the state of Wyoming. So that square represents currently how much land in Wyoming we're occupying with those turbines, given that 200 acre per turbine. So if we multiply all the turbines that exist in Wyoming right now by 200 acres, this is how much land area we're taking up in the state of Wyoming with our wind energy. Here's, if we build out all the turbines that are on the books to be proposed projects, that's how much land area we'll take up. I didn't put it on this map, but if we added all the potential, we'd probably take up a quarter of the state. I think a lot of us think about, land development or the patterns of development as being residential development as being one of the greatest drivers of land use change in the West. That was the paradigm that I certainly grew up with as a student in the West, was being really concerned about the pace of residential development. But it turns out that actually the pace of energy development, and this is all types of energy development in the United States, is more than double the rate of urban and residential development. So from an ecological point of view, it's absolutely something that we need to think about and carefully consider if we're worried about the species that we're trying to make room for in the landscape. So let's talk a little bit about how does energy development or wind development affect wildlife. There have been a number of studies that have been done looking specifically at wind energy and wildlife. This study by Smallwood in 2013 estimated, and that was 2013, so 5 years ago, about 500,000 birds in the United States and almost 1 million bats were being killed by wind development. So I think we can safely assume that we're killing at least 1 million bats a year just with what we've got, at a minimum, and certainly more birds than 500,000 now. So from an ecological point of view, birds are one of the species that we're most concerned about with wind development. This Erickson's looked specifically at small passerine birds, so birds that use the sagebrush ecosystem would be things like sage thrasher and sage sparrows, brewer's sparrow, those kinds of birds. They accounted for about 65% of the mortality that were in that 500,000 birds figure. And if they estimate that at least three birds, small passerine birds, are killed per megawatt per year. If you multiply those numbers by the number of turbines we have in Wyoming right now, we're killing about 5,000 of those small passerine birds per year right now. So that means if we multiply by 5 the projects that are on the table, that's 25,000 a year of those birds that we're basically already have decided we're probably going to let go of. Not a small impact. Another study looked at displacement of birds. So when you think about a turbine, what's happening to that? Is that land underneath actual habitat that species are using? And we're still learning about that and trying to understand that. But one study that did look specifically at that, this Schaefer study, they found that 7 of 9 grassland birds were displaced within 300 meters of a wind turbine. So that essentially means that habitat underneath is not really habitat to them. Might as well be a parking lot. They're leaving to go somewhere else. Here's a map that Amy Posewitz was involved in this study. We mapped out different classifications of birds that would be affected by wind development. This is the one for sparse grassland birds. We have great sparse grassland bird habitat in Wyoming. Should surprise no one to go along with our great pronghorn, mule deer, and eagle habitat. So I think my point here is that southwest Wyoming is some of the best sparse grassland bird habitat in the state of Wyoming, which is also where these wind projects, most of them are likely to be sited. So pretty large conflicts with grassland birds overall. So let's talk about eagles for a minute. Eagles are one of the species that is of great concern with wind development, and Chuck has a wonderful exhibit downstairs or across the way on eagles and describes some of those impacts. From what we know in terms of the actual numbers, some early studies that were done in Altamont Pass in California found that about 75 deaths were recorded of eagles in a 3-year period. And then there was a sort of large-scale study that Padgel did in 2013. And this is in addition to the California, so it doesn't include the California data. They reported a minimum of 85 eagle deaths from wind turbine collisions from 97 to 2012. 29 of those were in Wyoming. And what I'll draw your attention to is they were very pointed in saying this was a minimum number. And the reason for that is that eagle fatalities are not required to be reported by companies on private land, nor do they have to monitor. So the reported deaths from eagles are essentially incidental findings. This would be a staff member, maybe from an environmental consulting firm that was doing another survey and came upon an eagle and decided to report it. But they don't have to report any of them. If they get caught from the Fish and Wildlife Service, they can be fined greatly, but they are not required to report them. So that makes tracking and understanding just how many eagles we're losing from the current wind turbines we have a pretty tricky thing. What we do know in Wyoming was that the Duke Energy facilities and Pacific Corps facilities in southeast Wyoming, and that they were fined for eagle fatalities. They were documented. This was a court case some of you may remember a few years ago, that they killed 52 golden eagles at the 2 combined sites of 303 turbines during a 4-year period from 2009 to 2013. And they were required to mitigate those, and that's an ongoing steps that they're taking to mitigate those losses. But from an impacts point of view, the fact that there were 52 documented eagle fatalities in that 4-year period is pretty astonishing, and I think it also points to the eagle resource that we have in Wyoming. So here's a map of nesting density of golden eagles for the entire western United States, And note that Wyoming has some of the bluest, best habitat, nesting habitat for golden eagles in the entire West. So if we're going to be the center for wind development oncoming and we have some of the best eagle populations, you can see where the conflicts might arise. Also, and those deaths were just looking at the fatalities on the wind turbine farms themselves, but we also know that fatalities from transmission lines are another big factor, and you have to really add those potential fatalities on top of the actual facilities themselves. Bats are another species of great concern. So researchers have tried to understand and look at this. Why are bats such a problem? And with wind turbines, and they have found that they think they're actually attracted to them. Maybe they view them as like a tall tree, and wind goes around them, and that's where an insect might congregate. So they're looking to these turbines as areas to forage for food, and unfortunately get caught up in the blades and get killed along the way. There was a big study done in Canada. They found that each turbine killed 15 bats per year in Canada, which amounted to about 70,000 bat deaths per year in Canada. We've got our 888,000 in the United States. Just multiplying out the numbers that Ed Arnett put together for bat fatalities, we could estimate that we're losing at least 9,000 a year with current facilities in Wyoming right now. Sage-Grouse are another species that are of concern. This is a species that I've worked on quite a bit actually over the years, not specifically looking at wind turbines, but I think the jury is still out on exactly what the impacts of wind turbines are on sage-grouse. Chad LeBeau wrote, his research group at West looked at sage-grouse populations and wind turbines, and they didn't find the magnitude of impacts that they expected, the displacement they expected. They did find what they said impacts of selection on summer or brood-rearing habitat within 1.2 kilometers. So this means basically grouse are kind of moving away from the wind turbines for summer and brood-rearing habitat, but they were selecting away from it, but they weren't entirely avoiding it either. So there might be some compatibility there. It may not be that, if there's a good news picture, it may not be as bad as we thought for sage-grouse. But certainly thinking about sage-grouse is really important because Wyoming does have some of the best sage-grouse habitat in the West. We have 38% of the overall Western population, or global population of sage-grouse. So we have to keep our eye on that, I guess is how I would say it. Other species that we don't really understand the effects for, one of them is pronghorn. And this is something that my colleague Matt Kaufman at the University of Wyoming is looking at. He just started a new study in Shirley Basin to look at the patterns of pronghorn use in the Shirley Basin before a big wind facility goes in, and then he's actually going to measure their response. Here's the map of the state of Wyoming that the Wyoming Migration Initiative put together of all the known migrations in the state. And here's the Shirley Basin pronghorn, bighorn sheep in Laramie Peak, Platte Valley pronghorn, and then others that aren't even mapped yet that we need to be thinking about. Okay, so what can we do about, given those two things? Given we know wind energy development is likely knocking on our doorstep and coming, and given that we know that there are significant wildlife impacts, especially to birds, what can we do about it? So conservationists have come up with what they term a mitigation hierarchy, which is sort of how do you think about those impacts in a sort of systematic way. And the hierarchy in broad terms goes like this. First, you should try to avoid the impact. That would be the best case scenario, is we just avoid them altogether. Next, if you can't entirely avoid them, let's at least try to minimize those impacts where they occur. And lastly, if you can't avoid and minimize, let's try to offset and protect other habitat for those species. This kind of wordy graph is basically a chart that shows all the different things you could do for wind energy mitigation. starting at the top with siting. This is the best. This is the avoid. Let's try to site these wind farms in the least impactful places. We should do that first. And then we can go down the list. If we have to put them in places where wildlife occur, let's then work on other things we could do, like curbing the speed or detecting species, and I'll talk about that a little bit at the end. But siting is the best, and that's where we've really focused our effort at the Nature Conservancy. There have been a number of papers that have been written by scientists at the Conservancy looking at, hey, you know, could we, if we wanted to site all of the development in already developed areas that are, humans are already using these areas on the landscape, could we still meet some significant renewable energy, clean energy goals doing so? And this paper by Joe Kiesecker actually in 2011 said that. It was called Win-Win for Wind and Wildlife. We can have both is essentially what he showed from a scientific point of view. And that we could generate over 3 million megawatts of power just on our disturbed lands in the United States alone, if we only sited in our already disturbed lands, essentially saying mathematically it's possible to have both if we do that. For reference, here's the map of what I would call disturbed lands in the state of Wyoming. This is a map we did with the Game and Fish back in 2010, and we took all the roaded network areas, the ag lands, existing oil and gas developments, coal fields, as a way to say, hey, you know, we could put our wind turbines, and let's marry this map with the places where wind resource is, and let's try to push development to these already disturbed places. So the Conservancy started an effort like that. They called Site It Right, and they built this out for Oklahoma and Kansas, and I've been involved with, over the past year, with providing this same information on wildlife resources in Wyoming to grow out this effort for, actually they're doing it for the entire Great Plains and Rocky Mountain states. So I'm just going to show you a little bit about this, this planning tool and what they developed. So they basically identified key wildlife areas like bald eagles and lesser prairie chickens and bat caves and other T&E species, and basically put them all together on a GIS map to say, these are all the wildlife resources that we know about. And then they married that with, okay, well, we know that wind developers can't put development everywhere. There are restrictions to where you can put a wind farm. So then they mapped out all those things, things like special air use space and airfields and other wind facilities and slope that doesn't work for a wind farm. And they put those all together in a GIS database. And then they married the two. And they said this area, these areas in green, these are both low risk for wildlife and they're technically feasible for wind development. So let's try to work with companies and encourage siting in these green places. Let's try to go there. And then they worked out the math on how much capacity you could put if you sited in these green areas. And they showed that you could do 20 times the Department of Energy's figures on wind energy development alone if you just went to the green areas. And they put it on the web as a mapping tool, and they're, like I said, they're currently in conversations with energy companies to see if we can encourage development in the green. And so, like I said, we've been working in Wyoming to be a part of this Site Wind Right effort, and providing data in Wyoming to build out the tool for all of the Rocky Mountains and Great Plains states. So we gave them data, for example, on eagles. This is a marrying of a couple different models, both eagle breeding areas in the state of Wyoming, as well as some other special use areas for raptors. We gave them the data on sage-grouse. So these are the sage-grouse core areas, the best breeding habitat for sage-grouse, as well as lecking areas. Crucial winter range for big game like mule deer and pronghorn. And we're in the process, see the draft up there, we're in the process of vetting this and putting this all together in this tool. So I just want to talk a little bit about on-site mitigation. I was fortunate to get to go to the Duke Energy wind facility last month and got a chance to learn about, for example, as I said, Duke Energy, because of the lawsuit, had been required by the courts to mitigate their eagle losses, and they installed this Identiflight technology. Basically what this does is it sits here and it takes pictures, a video of the landscape looking for eagles. And when it finds one, it's machine learning, so it learns eagles, it actually adapts, and when it finds one, it turns the turbine off that the eagle is near, which is, I think, astonishing. And then it turns it back on when he's gone, he or she is gone. It can do this within 30 seconds. It can restart the turbine. Pretty amazing technology that we could use in cases, especially where the wind turbines are already built in places that we know are sensitive for eagles. Bats, mitigation for bats is something that also many scientists are working on. And like Vestas, has technology that their claim can reduce bat mortalities by up to 60% by using ultrasonic broadcasts. I don't know really anything specific, and Chuck may know more about this type of technology and he can expand on it, but using ultrasonic broadcasts to deter bats from those areas, it would be another example of something you could do to minimize those. Speed curtailment would be another. Can we just reduce the speed of the wind turbine a little bit? And Arnett actually looked at this as a mitigation strategy, and they only found a 3% reduction in power loss, but 5 times fewer bat fatalities with speed curtailment. So there's something else you could do just by reducing the speed of that blade a little bit. I think we're all of us in this room, I think it's safe to say, treasure our wildlife in Wyoming, and we would like to be able to have a future that has clean energy and room for our wildlife. And I think the technologies exist both on-site as well as siting level. We know enough, we have great maps of where our resources are, and we could plan around them. We could also consider technologies, clean technologies that aren't as harmful to bats and birds, like solar panels, take up far fewer footprint on the landscape, and we can still generate that electricity. So I think there is a really important conversation that the public needs to be having about these technologies and what's coming, and encourage you all to engage in that conversation. The companies will keep looking for those permits to site those wind turbines, and unless we engage in this conversation and really try to empower our policymakers to be very thoughtful about where this development is, I'm sad that we will wake up in 15 or 20 years and find that there is a lot of energy development where we didn't really want it to be. And so we have a moment now at this energy development is at our doorstep, and there is time to help influence this conversation. And so I hope I've provided some good information to give you all some things to think about the impacts of energy development, wind development in particular, on wildlife, and the wind energy that is coming. So, and I'm happy to take any questions that you may have. Thank you.